All right. Well, good morning, good afternoon, good evening to all of you from wherever you are in this world. My name is Michael Redlick. I'll serve as your moderator today. I'm checking in from Flemington, New Jersey. So if you wouldn't mind sharing where you're from around the world, that would be awesome. I'm happy to introduce Christopher Judd today. He is the uh, Chief Technical Officer and Partner at Manifest Solutions, and he's going to talk to us today about Open Telemetry. All right, take it away.
Thanks, Michael. Well, as Mike, I'm so excited that you're all here today and are looking forward to learning about enterprise observability with OpenTelemetry. And like Michael said, I'm Chris Judd, and I am the CTO and a partner at Manifest Solutions. We're just a mid-size consulting company based out of Columbus, Ohio. Obviously, I'm a Java champion. I'm also John Maxwell certified as a coach, trainer, and speaker in the leadership space. And I'm also certified in AWS. I've been running the Central Ohio Java Users Group for about 26 years, and I've co authored several books. When I'm not writing code, I tend to write words. So some of them are Java related, and then a children's book as well. And I thought I'd start by explaining how important observability and OpenTelemetry is by telling you a little bit of a story that happened to me a couple of years ago. One of my clients called me up and said, "Hey, Chris, we are having an interesting performance problem we're hoping that you can help us out with. It's occurring for only one of our clients. However, that client of theirs was their largest client, and it was also during the busiest time of the year. So it was a mission critical application that just was not performing well, and they needed it fixed right away. And they had actually already been spending 2 to 3 weeks trying to diagnose what that problem was. And what they were observing is not all the time, but some of the time for that one client only wasn't affecting any of the other clients. They were getting going from sub-second response times to sometimes a minute or two with each click in the web interface. And they just didn't know what to do anymore. So they called me up and said, "Hey, Chris, can you help us?" And the first thing I did was map out all the hops in the user interface. So from the user, they were using browsers, obviously. It would go through a bunch of hops till it would get to our web application, talk to the database, and respond. But again, it wasn't happening all the time. So the first thing I did is, because I knew this application was capturing all those transactions and we had a way of manually replaying them, we tried to duplicate this multiple times and we could not reproduce any of those performance problems. We even had somebody VPN into a machine in the same city that that client was experiencing problems and we couldn't do it. So what we decided to do was get everybody online, and we had the client go through the processes themselves. And for 45 minutes, we spent trying to reproduce it and not having a problem. And just as we were about to hang up, at the 45-minute time limit, they started experiencing the problem. And we immediately started watching everything that was going on and trying to figure things out. And so after about a half an hour of reproducing this really slow performance that we got to see for the first time from the browser, they saved off a HAR file. I went back and looked at the logs for those times, starting with the application server. There we had access logs enabled so we could see where the time was being spent. And it's probably going to come as a complete shock, but we had sub-second response times as far as the application server knew. And so I was scratching my head. How could that possibly be? Now, of course, there were one or two that were maybe 3 to 5 seconds, but those were known slower endpoints, not really a big deal. So I started saying, I need to go look further up the stack. So we got the logs from the application server. We were able to look at those. Of course, correlating what was going on between those was a challenge because they had different timestamps. And the only way we had to correlate was with timestamps. But we weren't seeing any issues there. They were all sub-second. We had also had the network operations on the line at the time. They turned on PCAPs so we could get PCAP files out of our F5. And I don't know about you, but if you've ever had to go through PCAP files, it's not a fun way of digging through logs. And the timestamp was yet a different format. And we still weren't seeing anything. It was all sub-second still. Going back up the stack one more time, there was a third-party service that was used as our WAF, our web application firewall. And at first, everyone said there was no way of getting timings. I was able to do a little bit of research and find that given the right header file or the right headers, we could enable performance testing there and get some of those metrics and logs. So fortunately, we had done that before we started this test. And according to that, again, we are getting sub-second response time. And on their side, as far as we could tell, everything was normal. So with some investigation, we felt like the only thing that could possibly be an issue was the WAF. And so we called up our provider and said, hey, we think there's something going on in your network. Could you help look at it and tell us if there's any issues that you're experiencing? Of course, the response was, no, it's not us. We did some more research, looking around, still wasn't any of our stuff. We called them up, please, can you look again? They said it's not their stuff. Finally, a couple days later, they called back and said, you know what, we did find a node in that region, in the Virginia region, which is where their client was, that was having some problems. We've rebooted it. Let's see what happens. And the problem went away. But what I want you to get from this experience is it was very painful trying to correlate all that information across all those different systems, being based only on timestamps and having to figure out how you enable and disable it on third-party products. And so to give you a little bit more insight, the reason only that client was experiencing is because the WAF was spread across multiple regions and they were only having problems in that one particular region that we happened to be using for that particular client. So end up having a nice happy ending. We got the client up and running. They were able to deliver what they needed using the software. Things were good. But that left me thinking, there's got to be an easier way of doing this. I hadn't run into this type of experience in years. There has to be ways that we've evolved and can solve this problem. So that's what we're here to talk about today. And let's start with observability from a definition standpoint, because the title is Enterprise Observability. So what is observability? It's the ability to measure how an internal state of a system can be inferred from the knowledge of its external outputs. And if you've never seen this, O11Y is the shortcut for observability because it starts with an O, there's 11 characters, and it ends in a Y. So I think about observability like this. Several years ago, my son broke his wrist. When we went to the doctor didn't slice open his wrist and look at the broken bone. Instead, using the idea of observability, they observed the internal state externally. So what they did is they felt around, felt the tenderness, the swollen, and then they did an X-ray to determine the broken bone. We can do the same type of thing with our software. In 2016, Twitter, now known as X, formerly known as Twitter, wrote this blog post on observability, and they talk about having 4 pillars of observability. So monitoring, knowing whether a system is up or not. They had the ability to do alerting. So if a system did crash or go down, they could notify people responsible for it, maybe using something like PagerDuty. Be able to watch a distributed trace. So any transaction that happens in the system, they could watch it from the client perspective all the way through all the different components in the architecture to see where a problem might have occurred. And finally, log aggregation, that they could analyze what was going on with logs, find patterns of maybe errors happening after a deployment, things like that. And that's how they look at it. And along with that log aggregation, not having to SSH into each of those individual machines to look at the individual log files, but having them in one common repository. Well, OpenTelemetry, we're going to find, uses 3 of those pillars, and observability in general uses metrics to know what's going on inside of your system. From a Java perspective, you might use JVM metrics like memory, the heap, CPU utilization, things like that. Distributed tracing, again, to follow that transaction from the user perspective all the way to the database and back, and aggregating those logs so we can look at individual details of the logs, the comments, patterns, types of errors that may be occurring. And then telemetry is another definition I thought we would go over. And this is the idea that we are going to remotely and automatically gather information from our equipment, or in this case, our software. And so you often see this in an environment where maybe you have IoT devices where you're collecting that information from different sensors and aggregating it in one place. And I really like where the Greek word comes from, where tele means remote and metron means measure. So we're going to remotely measure what's going on in our software. And types of things we might do by gathering telemetry from our software is determine where performance issues are. Are our application components performing slowly? Is the database performing slowly? Are we talking to a queue that might not be performing accurately? Are there application crashes, errors, exceptions going on inside of our system? General usage statistics, like our metrics, like our heap utilization. From a user perspective, we might gather things like feature usage or user behavior. Do they always go through a certain path within our application, for example? Our hardware statistics. Do we have enough hardware memory or disk space? There's so many times I have problems in production because we ran out of disk space because it wasn't being monitored. And then finally, from a security perspective, threat detection, investigation, those types of things. And we're here to talk about OpenTelemetry, but some of you are probably thinking, Chris, we already have systems in place for providing observability, monitoring. You might have an application performance management tool in place to give you a lot of this information. Why do we need yet another thing to help us with doing this as OpenTelemetry does? Well, I'm here to say that, spoiler alert, OpenTelemetry doesn't replace any of these tools that you might already be using today to gather this information. Instead, it augments those. I know when I first started looking at OpenTelemetry, I thought it was going to be an alternative to these, a free and open source alternative, but it's really not. I want you to think about OpenTelemetry like JDBC. JDBC is an abstraction, an API that you can interact with regardless of the database on the back end. And we're going to see here that OpenTelemetry is going to provide us the SDKs to interact, gather the information from our application, and submit it to these types of tools. So you might be using some of these already, and that's fine. It will probably work with those either today or in the short future because the industry is really adopting OpenTelemetry very quickly. So let's talk about, why do we need OpenTelemetry when we do have all these solutions today? Well, one of the big ones I found in both the example I gave you and further exploration is we have a lot of inconsistent visibility. And what I mean by that is we have a lot of components in our applications, in our architectures that may have monitoring, but may be tied to a specific monitoring. For example, in AWS, you might be using Lambdas. And by default, it's going to write all those metrics to CloudWatch. Well, maybe the rest of your application is all on-premise and you're not using CloudWatch to capture this data. You might have some open API vendor tool, and maybe it only does tracing, but maybe to a particular protocol, to a particular vendor like Jaeger. And then maybe inside of your application, you've chosen to use Prometheus and Zipkin. And so all that same information is being captured there. And then you may also have other components that aren't being captured at all. Well, just like my example before, we don't want to have to go to a bunch of resources and make guesses to try to figure out where all these issues are within our software. And so we have this inconsistent visibility today, most likely, if you haven't taken steps to use OpenTelemetry or try to coordinate all that and maybe use some abstraction layers. The other thing is our software is just getting so much more complex. User requests should come into an API gateway and go through lots of different web services or other types of services or event-based systems like Kafka, and being able to monitor and see where all those transactions are happening is rather complex. And so trying to aggregate all that information from different sources can be challenging. And so this is why I think OpenTelemetry is that solution for us. It is an observability framework provided by the cloud native Computing Foundation. It is 100% free. It's also open source. And what OpenTelemetry is trying to provide for us are APIs, libraries, and agents for collecting our metrics, our distributed tracing, and our logs. So it all aggregates in one way. And they provide lots of libraries for different languages to make it easy to integrate all of this together. Now, if you haven't heard of OpenTelemetry before, or you're like, it just all of a sudden popped up on my radar, is this like a brand new technology? It's actually been around for a while. What happened were there were these competing open source alternatives of open tracing and open census that gathered different information. They merged together to give us OpenTelemetry. So one was focused on metrics, one was just focused on distributed tracing. They brought them together to create OpenTelemetry and then added logging on it as well. So now with OpenTelemetry, you get all three of these. If you go back and you're using older versions, they might not support logging, and older versions might not have metrics, but if you are using the current releases of OpenTelemetry, all three of these are supported now. Now, because these are different libraries, they're all in different levels of completion. From an API perspective, they're all considered stable at this point. From an SDK perspective, some are stable, some are in a mixed state. In the case of Java, we are lucky that the SDK in both tracing, metrics, and logging are all considered a stable state. And the protocols themselves too are all in a stable state. If you want to get more details about that, or if you're using a language other than Java, you can look at this best compliance matrix, and it will tell you what aspects each of your independent languages are currently supporting. So if you're using something else other than Java, you might want to check this out. But Java has been really at the forefront of OpenTelemetry. It's been, I think, where a lot of the reference implementation work has been done. So let's talk about distributed tracing and metrics in a little bit more detail. So when we're just talking about distributed tracing, it's a set of events that are triggered by the result of a single logical operation or logical business transaction, such as a user clicking on something. And what this trace is going to do then is consolidate all the various components of your applications or systems of your application to produce a distributed trace that contains the events across network and security boundaries. Within each transaction or distributed trace, it's going to create spans that represent operations within that transaction. And each one of those is going to have an operation name, a start and a finish time, possibly sets of attributes to further define the state of that particular trace. And if we look at that visually, you might have a logical set of services where, again, a browser makes a request to an API gateway. The API gateway probably does something with security to make sure that the user is valid. It may also call then a web service that might call another web service that might talk to a database, and it might call another web service that talks to a different repository. Ideally, you want to get all these hops included in that distributed trace so you have full visibility or observability into what's going on. And what happens is a trace is created, a distributed trace, which would represent that entire transaction. And then at each network boundary or each logical component, it would get broken up into spans. So here's a span during the API gateway. Here's one during the security, service A that calls service B, and then service B that calls the database. Each of those are represented as spans, so we can see how much time it spent at each of those logical boundaries. Now, those boundaries, as I mentioned before, could be network or security boundaries, or it could be logical boundaries inside of your application, such as if you're using a Spring application, we'll see later, you typically have controllers. Controllers call services. Services call repositories. Repositories call the database. Each one of those could be also represented as a span. And then you also have metrics. Metrics provide information that is captured at runtime. So here would be an example of a metrics in the form of JSON, where we are interested in knowing whether the garbage collector paused. So these would be JVM metrics, but you could have metrics in your applications or certain libraries. And the measurements that this one's capturing are examples of a count. So how many times was there a garbage collection pause? We can see here that there's a value of 3. What was the total time spent in a pause? And we can see that time here. And what was the maximum amount of time it spent in a pause? And we can see that here. But we could gather lots of other metrics as well. So we're going to find out how OpenTelemetry does the distributed tracing and the metrics now. In order to do this, OpenTelemetry has a pretty extensive architecture. So let's talk about that architecture. This is what it looks like. We'll break down each individual component. At the top, we have the API layer. And this API is a language-independent protobuf interface. So it can support any number of languages. Also in this API layer, it also provides a protocol. That protocol is the OpenTelemetry protocol, which uses the initials OTLP. And the types of things you see in this API besides the protocol is you see an API for trace, you see one for metrics, and we'll talk a little bit later about what is a context. So it provides context. And since this diagram has been made, they added logging as well. So that's the API layer. Again, language independent protobuf. Then we have the SDK. And the SDK, there are implementations for lots of different languages. So Java, C#, Go, JavaScript, Python, Rust, C#, Erlang, languages like that. And in there, they have language-specific implementations of the API. So you have trace, you have metrics, you have logging. They also have concepts of propagators that we'll talk about more later. We'll talk about processors and exporters in more detail later as well.
Hey, Chris.
Yes.
I have a question here from Vincent. He says, you do distributed tracing with a correlation ID that is attached to request references to a transaction chain. Yes.
So that's a great question. And absolutely, OpenTelemetry does that. And that is what the context is in reference to. It's going to be that correlation ID that goes from the beginning of the transaction all the way through the application. And we will talk in more detail. There's several different correlation IDs or contexts you can use. And we'll talk about some of those alternatives, why you would use them. And we'll actually watch one of them as it goes through the system in a demo. So absolutely, we do have a correlation ID. The SDK, as we can see from the lines here, can either talk directly to a vendor product or they can go to an OpenTelemetry collector. So you can do it in either way. We'll find out more about the collector in a little bit, but the collector is a separate running application that can collect the information for performance, scaling reasons, and it can handle some of the duties that you might have had inside of your application previously. But again, we'll talk more about that in detail. And then finally, there's the vendor products at the bottom of this, where they're going to actually ultimately collect the data. They're going to separate themselves out by giving you visibility into that data that's been collected, providing analytics, other types of things that you might want to get. So that's where their value add is. Both at the SDK and at the collector level, we have these exporters. This is how we are going to get the data out and transfer it to something else. There's a lot of exporters that are built in, and there's a lot of exporters you can add third party. So we can see here that we have ones like Kafka, we have ones like OpenCensus, we have Jaeger, Zipkin. If you're not familiar with Zipkin and Jaeger, those are open source distributed tracing tools. But there's also its own, OpenTelemetry has its own exporters based on their own OTLP protocol. And that is what you'd probably want to use. But if you had one of those other tools, you have the option of using those as exporters too. And we'll look at exporters in more detail in a minute. So what support is there? There's a lot of support. And if you're looking at this and thinking, wow, that slide looks familiar, it's because it's the exact same slide as before with just the title changing. All those products that you might already have in place already support a lot of the OpenTelemetry. You know, I kind of think of it this way. Back when we had a lot of MVC frameworks, they all implemented their own tag libraries, and everyone's like, you know what, 90% of these tag libraries are identical. Why is each framework maintaining and creating their own? Shouldn't we just have one set? And that's when we got the JSTL standard tag library set. Kind of the same thing here. Previously, all these vendors were implementing their own libraries that you would embed in their applications and reinventing that wheel over and over again. And I think a lot of them were finally like, why should we be doing this? That is really a commodity, and we want to be in making the data actually provide value. So most of them are hoping that you use OpenTelemetry for that reason, I think. Again, pointing out this is more like JDBC than a MySQL database. And to point that out, historically, we might have used their native libraries for those products and embedded those in our application. And if you were doing both metric collection and distributed tracing, you might include multiple libraries. But now with OpenTelemetry, we could just include the OpenTelemetry library, and it gives us flexibility because now we can have multiple on the back end. We can switch on the back end. There might even be products that don't exist today that we might want to take advantage of later. So this is one example where you might have those exporters configured to go to each of the applications themselves. But more likely, what you're going to use is that concept of a collector I talked about before. And the idea of a collector is your applications can grab that information and immediately send it to a collector. And that collector will do something with that information. And you can stagger these collectors in a hierarchical way. For example, if you're using virtual machines or containers that have multiple applications, you might use a collector like an agent on that virtual machine, have all the applications write directly to it. And then inside your region, you might have another collector, which might be a gateway collector that all of those agents are writing to. And then that gateway is going to write to the end products that you might want to have collecting that data and providing the insights you need to the data. So this particular example shows you could actually have two distributed tracing repositories that you're writing data to, in addition to a metrics repository like Prometheus. And like I said, in the future, there might be some new ones. Maybe someone comes along with this machine learning or artificial intelligence based one. Nice thing is, as long as it supports the OpenTelemetry, you could add this here without even redeploying your applications. You just change some configurations to your API gateway, and now you're writing to a whole new vendor product that you didn't have before. So it really helps to abstract what's going on inside of our application and the changes. Now the collector typically is going to use protocols like either OTLP, the the OpenTelemetry protocol, or gRPC, or HTTP. So I think this model too is a really valuable model. I know I've used vendor products in the past that had embedded libraries, and they would collect all the data inside the same JVM, consuming valuable memory and CPU utilization that my application needs. By using these collectors, we can offload that. We can fire and forget, and those can be handled and scaled separately from our application. So what I want to do now is give you a demo of how this works. And what I've decided to do for the demo is just use the Spring Pet Clinic. And it's not the MVC Spring Pet Clinic. This is the one version where it has an Angular front end, a Spring Boot REST, and then a database on the back end. So
Chris, before you get into that, there's another question.
Yes.
It says here, I'll show it too for everybody. This is from JP Andres. He says, hi there. Until now, Micrometer was presented like the SLF4J for metrics and traces. How does it play with OpenTelemetry?
Yeah, great question. So Micrometer doesn't necessarily go away, and I think Micrometer feeds into a lot of the metrics that OpenTelemetry is going to capture. And Micrometer is great for Java, but it's only for Java. You may have other things in your system that are not Java related, and you may have things in your architecture that are vendor products like F5. If I didn't point it out on the slide, but F5 as a firewall supports OpenTelemetry. So instead of having to read those PCAP files, I could have that all captured right in one of these repositories by using OpenTelemetry. So it's a much broader view than Micrometer has, but they do work together.
So it is Micrometer versus Micrometer?
Does it matter? I can't remember the details. But yeah.
So
okay, so we're going to go through this demo, and I'm using this demo because I want you to see ultimately from the browser front end using Angular or any JavaScript framework how we're going to see those distributed tracing. But initially, we are going to start with just the Spring Boot REST here and show it because this is a Java conference, and we'll spend a little bit less time on the JavaScript, but to give you an idea of how it does work. Now, we could go get the SDK from OpenTelemetry, and we could start writing our own code to capture those traces. But really, who wants to do that? They do have a library that aggregates that functionality and makes it easier for us. It's called the OpenTelemetry Instrumentation for Java. And what this is an agent that putting it into using the Java agent, it is going to then do bytecode manipulation to gather a lot of common metrics you might want to have based on common frameworks. So this is a Spring Boot application. Like I mentioned before, they have controllers, services, repositories, talking to a database. It knows about all that, and it's going to instrument that with us, for us, without us having to write any bits of code, without doing any configuration. So that's what we're going to do initially. And so it is using the Java SDK for OpenTelemetry. And just like we said before, there's these exporters. So we are going to start with the easiest exporter provided, which is the log exporter. And so you can look at the documentation there. They have the log exporter, which is just going to write the system out. We can set some system properties to tell it to use those. Now, by default, the OTLP is the exporter by default, and we'll look at that one as well. And that one is typically used then to write to a collector. So without any changes to your application, to your code, all you have to do is add this Java agent with the OpenTelemetry jar, tell it you want to use the exporters for logging, and it will start logging. So let me bring up my terminal. And just to give you an idea, I already have the Angular application running in this tab. This is where I'm going to have Spring Boot running. And over here is where I use Docker containers to start up the collector and some other services using a Docker Compose. So let me start up the application once without OpenTelemetry. So just java-jar Spring Pet Clinic. And if you've done any Spring, you'll see that this logging looks like any other Spring Boot application that starts up. Not very interesting. If we want to see it, there is a Swagger UI to it. So this is what it looks like when it's running. Now that we've seen that, I'm going to restart it. And this time, I'm going to start it with that agent. I'm going to tell it I want to export logging. I want to export the tracing to the logging exporter, metrics to the logging exporter, and logs to the logging exporter. Again, no changes to the app. And when I run it this time, we're going to see a lot more stuff coming out in this logs. Now, the first thing I want you to note is all these zeros. So somebody asked the great question earlier, is there a context or a correlation ID that gets shared? And when you see these zeros like we see here, that basically means this was a system event and not a user event. So there's no correlation ID with this because there was no business transaction started. And we'll also see that it is capturing information like calls to the database for us. Now it's hard to see here. So what I've done is I've created some slides and done some syntax highlighting to make it a little bit easier. But when the agent first starts up, it's going to tell you what version of that agent is running, because not all versions may be compatible with the collector and things. So it tells you what version. And then this particular application, what it's going to do is it knows where JDBC boundaries are. So you can see here that it's capturing a trace at the database level, the JDBC level. It's also capturing the SQL statements that were executed. And here's that trace ID for us as well. So we can see that this database call and this database call are a part of the same transaction. And this database call down here is also part of that same transaction. Now those database calls came from a repository, or actually we'll take one step, intermediate step. It came from a Hibernate framework, and that Hibernate came from a repository, specifically the find all method on that repository. And a transaction was started to handle that. This is a database transaction, again at the Hibernate level. And the repository was called from a MVC, web MVC, or a controller level, specifically the controller pet rest list pets. And here's that correlation ID. And this came in as a request to Tomcat at with an endpoint of /petclinic/API/pets. So you can see we can follow that whole transaction all within inside of our logs right here. So here's more for your money OpenTelemetry. Instead of using a library that wraps your JDBC, all you have to do is add that one OpenTelemetry jar and you get all of your SQL statements that you might have had to use other ways or enabling flags to do before, and you did a lot more data using it this way as well. So really nice, handy, easy to incorporate. It also captures metrics. So if we were to look at that output, you would see at different times, it's going to grab the metrics that you might be interested in, like database metrics. So it knows about the database connection pool, and it captures how many connections were there using a gauge. And it grabs CPU utilization using a gauge, gives you that information, the number of sessions from Tomcat, and so on and so forth. So it's capturing all those metrics for you right there, again, without making any changes to your application. So let's actually invoke one of these. So I'm at the Swift. I'm going to call a get on pet types. I'm going to try it out and execute it. I'm also going to, I'll do the other one in just a second. So, and actually, I forgot. This one is just doing the log. So you will see it. It's down here at the bottom, but it's not as easy to see. So I'll show you. It's right here. Here's my get. And if I was to trace back up, you would see all the calls to the database and things right there. But let's make this a little bit more interesting. Let's add the collector to the mix. And so the collector, again, is this component right here that is provided by OpenTelemetry. It's written in Go, and it has different configurable exporters. And the way that the collector is made up and configured, you have these different protocols that can come in and are received through receivers. So you can configure what receivers you want. And then there's these pipelines of processes. So you can do things to help scalability, like batch them up. You could do manipulation of the data. You could tell it, hey, if you get so many repeated messages, ignore them. So we have these processors that can do a bunch of different things. And then the processors feed into an exporter, and the exporters use different protocols then to write to those vendor products. So it's very flexible, and you have a lot of control of this. Now, I think the easiest way to run one of these collectors is using the Docker container. So that's what I'm doing here. And when you run this Docker container, or however you run the collector, you can give it a YAML file that describes what I just talked about. And so again, you're going to have receivers configured, processors in a pipeline, and then exporters configured. And all of these in this YAML file, this whole process right here is defined down here. So you see these pipelines. So we have a different pipeline for traces, distributed traces, and one for metrics. And inside the traces, you can see we have receivers. So what receiver are we going to collect the data from? We're doing it from the OTLP protocol. What processors do we want included? We're just using the batch one here, but there could be more in that collection. And then how are we going to export those? So here we're going to export it to a logger. By the way, the logging exporter is going to be deprecated in September of 2004, so later this year, and replaced with the debugger exporter, but it's still in development, so I thought it was still worth leaving the logging in here, but just FYI. And then we can export it to other exporters too, like Zipkin and Jaeger. That's that branch out model I showed on a previous slide. So we can write to multiple exporters. The metrics, again, we're collecting it via the OpenTelemetry protocol. We're batching it, and here we're writing it to logging and Prometheus. So here's our pipelines. If we want to look at our exporters a little bit, or our receivers a little bit more, we define our receivers up here. So we're receiving OTLP, and we're using both the gRPC and HTTP protocols in this scenario. The processors, we only have one configured here, which is the batch, but there's a lot of other built-in processors, third-party processors that you can get as well. And then for the exporters, we have a Prometheus exporter, a Zipkin, and a Jaeger, and we just have configurations telling it where to talk to those servers. So very easy config file, very straightforward if you understand the receiver pipeline exporters. And so I have that config file being loaded up via a Docker Compose file. And in this Docker Compose, I'm starting up Jaeger, Zipkin, Prometheus, and their collector. So when their collector starts up, this is where I'm configuring that YAML file to be read. And the ports that I have open to collect the data, and it also depends on making sure the other two have started up. So let me make sure I have this up and running. Okay, so I do have all those Docker images running, Docker containers running. And so now what we're going to do is we're going to restart our Spring Boot application. And we could specify that the exporter instead of logging is to OTLP. And we can specify an endpoint to point to localhost and port 4318. And then this other one here is the service name. And the service name is important because you want to, if you have multiple web services, or if you have a front end, you want to be able to tell which component this data was being collected from. And we'll see this in a minute once we add the Angular application to it. So this is coming from our REST component. So you could configure all this, or because the defaults are the OTLP and the localhost 4318, you just need to run it like this. So I'm going to go back here, up arrow, and remove everything I don't need.
So, Chris, we have another question.
Yep.
From Douglas, and it says, does the OTel collector have a Helm chart if I want to run this in Kubernetes?
So the question is, does it have a Helm chart? I suspect it does because of how popular it is, but I don't do Kubernetes, or I haven't done Kubernetes yet, so I don't know off the top of my head.
Yep.
Okay, so all we need is that service name. So now I'm going to run the collector again. Oh, sorry, our Java application again. Oh, I know what it is. Forgot the dash jar. Okay, so you can see now our logs are back to the way the logs looked before, because now, instead of writing it to the logger, it's writing it to OpenTelemetry. And if I come over here and I view the logs in my container, we will see them here. So let me come here and I will execute this again. We can see that it just rewrote our metric data. So our collector is working as we expect it to. Now, our collector is also sending that information to Zipkin and Prometheus. So if I go to my browser here and I run a query, we can see what's happening is it's collecting all this data for us. So we can see that the pet types I just ran is there, but to show it's collecting, let's do something other than the pet type. Let's do vets. If I run this query again, we can Oh, yep, there it is. Here's our vets. So it's sorting them by slowest first. And because that was the first invocation, pet types is going to be the slowest, but it's gotten faster here. So let's explore these a little bit. And this is not a talk about Zipkin, so we're not going to go into a ton of detail, but I want you to see how it collects this information. So when I click show, we can see here our pet clinic. This is our trace and the spans that make up that. So we can see the overall was the longest, and we had the call to the Tomcat, the call to the repository find all, to our model, and then to each of the database calls in a transaction commit. And as I click on any one of these, we can see the right-hand side. This is the attributes that were collected at each layer in that span. So we can see the database, what the SQL statement was. We can see information about our operating system. We can see the HTTP reference. We can see the thread that was involved. So there's a lot of detail it's collecting for us that we can utilize to resolve any issues that we might be having. And then likewise, the metrics are being collected here in Prometheus. So let me refresh this. And if we look here, we can do JVM. So the pet clinic was the name of our service that's collecting the data. And let's see, we might choose like no, let's not do thread count. JVM. I want to look for something with a gauge. Let's do committed bytes in memory. If I execute this, it gives me the different information in the JSON format, or more interestingly, if I graph this, we can see over here what's going on with the different aspects of memory, what's going on within the heap. So again, this is also not a presentation on Prometheus, but you can see that we're collecting the data through our collector, getting it to our vendor products. Okay, someone brought up that great question earlier about the correlation ID. That's referred to as a context. And so let's look at the context a little bit. So as a part of the API, there's also parts in the SDK, including propagators, which is how that context gets passed from the different boundaries in our application. Now, that was one of the things when I experienced that story that I told you before, is I was like, there's got to be a better way of tracing this. There's got to be an industry standard. And at that time, there was an industry standard really just starting, and that is called the trace context. And that is actually a W3C standard now. So now we do have an industry standard. Prior to that, there were different libraries like Zipkin and Jaeger that had their own formats, but each library had their own. And so the API has that context that can handle spans and correlation. They can be injected and extracted through common header information like the HTTP header to propagate those to the different levels of the system. So to describe this, we have that parent span, or the distributed trace, collects the information about a span. As it goes across the boundary, we need to share that, and we do that through propagators. So as it goes from our HTTP client to our REST, it's going to add it to the HTTP header. And then on receiving it in our API, it's going to pull that out of the header. So that's how it gets shared. And like I said, there is a standard finally from the W3C called the trace context. It has a way of defining the parent and then any spans after that. And so there's a version number in the parent. So far, I've only seen 00 because it's a relatively new standard. We have the trace ID, we have the parent trace ID, and then trace flags. So this is a standard going forward that you probably want to use. And to demonstrate this a little bit more, I want to now introduce the Angular application. So there is a JavaScript library for doing OpenTelemetry. So you could use that library. It's much like the library that Java has. But just like Java has the instrumentation library, there's a lot of frameworks that will then utilize that. So the OpenTelemetry Angular Interceptor is one of those that makes it easier to use than using the library itself. So if you were to implement this, you could do an npm install with a version of that interceptor. You would have to add some modules for doing OpenTelemetry. So we can see the interceptor module, the exporter module. This is where the propagation happens, and some more propagation as well. You would import those and some configs. So the config files are going to look like this. So the way my config file is set is not only is it going to propagate it, but it's going to write it in the console. So if you wanted to investigate and see what that looked like, whether it's in production or not, whether when it does log, it's logging the entire body. Just like for our REST, we gave it a service name so we could tell it was coming from the REST. We give it a service name, and this time it's going to say client. How often is it going to sample, and what log level is it sampling? And then finally, where is the server it's writing to? So that would have to be a server exposed if it's coming from the browser. But you could use a different collector for stuff coming from the web than is coming from your REST. And again, it can all get correlated through their correlation ID. Now, in order to do this, you will have to enable cores at the open collector level. Now, this is wide open for demonstration purposes, probably not what you really want to have in real life. Okay, so let's demo this. So here's our Angular application. And now I want to go to owners, perform a search. I'm going to go to veterinarians, and I'm going to, that performed a search as well. And if I go back to Zipkin, and I requery, we can see now we have the pet clinic client. So this came from my web front end, and so did these two. So I had 3 gets from that. And we can see here that there were 16 spans that traveled. And if we show, we can see them, and it's probably a little hard to tell, but they're different colors too. So the very first one from the client was purple. And then as it gets to the server side, it's green. And then it's looks like the same green down below till it gets to the database. And so we can see the HTTP post body here with the JSON that was sent with all the relevant information that the browser passed on. And so now we can see if we had other services, how those would, REST services, if my REST service called another REST service, how they would all be correlated then into single transactions from a distributed trace perspective. This is what the Jaeger looks like. So here's our client. Here's all of our server-side REST ones as well. Now we talked about that context, and I use this as an example in the context and the propagation. In that request header, depending on how it's configured, by default, it will send all of these. So here, this trace parent, this is obviously the W3C standard. This is another common standard. This is Amazon's. These B3s, these are Zipkin formats. So you could just, if you're sticking with the standard, go with the trace parent. Or if you wanted to make sure it captured everything, you could have lots of different correlation IDs all being aggregated together for you. That payload that went from the browser to our collector will look like this. So again, we have that trace ID, so we have correlation. What was the method type, the span ID, the time it took, attributes, like what was the browser type, status code, what was the endpoint it was hitting, and then the actual data that was passed as well. Now, if those libraries like the Java instrumentation library or the interceptor library don't do exactly what you need, you do have access to the tracing API and the metrics API. You could use those directly. So this is intended to show that. And so those frameworks by default, we showed captured all this common stuff. But if you had specific methods that you wanted captured, what you could do is you could add a Maven dependency for the instrumentation and add the annotations. And then inside of your code for that method that you wanted included, you want to be judicious about this because it will consume resources, but you can use their with span annotation here. And using that with span annotation will add another span inside of that trace. And if you wanted to capture data with that, you can get the current span and you can set attributes to that, name value pairs. That will then show up inside of your tool of choice or product of choice on the back end. We can do the same thing with metrics. So we can use their API. You do have to, again, make sure that you import the right dependencies. And then using the global OpenTelemetry get meter, you can give it a unique meter name. You can decide, using the builder pattern, decide what type of meters you want. There are gauges, counters, up and down counters, and histograms. So we can describe it with a particular name and a description, what the units are, and then we can give it a value and an attribute. So this would be a string attribute. You can also do it asynchronously. So if you want this to happen in the background, not in a specific cadence, we can do the same thing. So that there'll be a callback that will get called back when we record what that is at that particular point in time. And this callback will be based on a configuration of how frequently it should be gathering metrics. There's a lot of integration involved. So all of these extension points are places that you can plug in alternatives. And you can go to the OpenTelemetry registry and find alternatives for exporters, for example, or propagators. And you can search by language, you can search by type, and find out other alternatives for plugging in any of those. So in summary, I'm excited to say OpenTelemetry is a great product that I think is going to save us a lot of time. There's a ton of industry backing. All those vendor products are working together to make sure that it's a good solution and that their products can work with it. It's extensible, so any future products that we haven't even thought of can work as well with OpenTelemetry. Some resources you should be aware of. The documentation for OpenTelemetry is quite good, so you want to check that out. They also have a demo. Unfortunately, the demo does not include Java. It's TypeScript, Elixir, Go, JavaScript, and C#. So that's why I did my own. There's a dzone ref card on it. There's some books coming out for OpenTelemetry now. There's this awesome OpenTelemetry GitHub page that has resources, links to lots and lots of different resources you might find helpful. This is my contact information. I'd be happy for you to contact me with more questions, and I can take questions now if you wish. If you're interested in the slides, you can grab the slides from this code and URL right here. Do we have any questions, Michael?
Yes, we just have just one left over. I'll put that on there. This is from Stacy, who asks, I am finding that even in Java, many of the OpenTelemetry instrumentation libraries are in alpha. Have you come across this? And do you recommend using alpha releases in production?
So I'm not exactly sure what you're referring to. The APIs are definitely stable, and I've been using the instrumentation for Java, which I believe is stable, and I haven't had any issues. If you're referring to anything from the repository, I've not used anything from that repository, and if those are in alpha, I'd probably wait a little bit longer. But I've had a lot of success with those two particular libraries. And because Java is the reference implementation, they tend to be leading all of the other ones. The JavaScript I find to be in a little bit of flux. Every time I've done this demo, I've run into issues, for example, with version incompatibilities. But from the Java side, I've been very happy.
Yeah, we did one more just came in. Just let's see. And then this is from JP Andres again. So Dynatrace and New Relic would provide their own collectors.
Okay, so Dynatrace and New Relic could provide their own collectors. That's entirely possible. Or they could be packaging up OpenTelemetry. Historically, they both had their own collectors, or the libraries would just send it to their backends. But more and more, I see them encouraging people to go to OpenTelemetry because they don't want to have to write their own instrumentation libraries. So as long as it can write to OTLP or one of the other protocols, you might want to consider not using theirs and using the OpenTelemetry, or exploring whether theirs are actually OpenTelemetry, that they're just either rebranding, giving you a particular configuration. For example, in the Docker containers, there's an OpenTelemetry, and then there's an OpenTelemetry collab. If you look at the collab, it has a bunch more included exporters. And so what they may be providing is just a OpenTelemetry collector with an exporter specific for their backend product instead of supporting OTLP.
I think that's it. We had some nice comments here, so thank you, Chris, for the nice and thorough insights. So yes, this was awesome. Yeah, and so we got a okay, cool, thanks from JP Andres for answering that question. And yeah, this was great. And next up is Mary Grigleski, who's going to talk about entering the brave new world of generative AI with vector search. So that's coming up in the other moderator session, I should say, or on the YouTube link. And Chris, thank you very much, and thanks everybody for coming out. We had people from Germany, Ontario, Mexico, France, Nigeria, Senegal, and England for those that responded. And so we'll see you next time.
Thank you all.